In the next example, I'm going to solve problem 12, chapter 2. In this problem, we have a particle which we are shooting it upward with the initial velocity of v naught, which is equal to 80 foot per second. So we are shooting it from point A upward with a velocity of 80 foot per second. So obviously it's gonna go up and gradually it's gonna slow down because of gravity. And finally it's gonna reach to this top point. So it's gonna stop at this point for a moment, then it's gonna go down, right? So after going down, it's gonna hit the top of this cliff at point B. And there are a bunch of questions here. First of all, what's gonna be this h? Then the second part of the question is at what time it's gonna hit the top of this cliff? At what time it's gonna go to B? And also what's gonna be the velocity of this particle when it's hitting this point? So we need to solve all of this. And I would say before seeing the rest of the video, stop this and try to solve this problem yourself. Think about this problem at least for 10 minutes before seeing the rest of it. So I'm gonna assume you did that. So to solve this problem, first of all, I need a coordinate. You always need a coordinate to solve almost any engineering problem. So because we are starting from here, I'm gonna put the origin of the coordinate here, and I'm gonna call this direction y and this direction x. Okay. So this particle is gonna remain only in, it's gonna move just in the y direction. This little movement, it is negligible. So let's say there is no movement in the x direction. Okay. That's what the problem is saying too. And second, you need to figure out what equations you are allowed to use here. To figure that out, you need to figure out if the acceleration is constant or not. So when the particle is moving after releasing it, the only force that we have on the particle is a gravitational force. And also, because of that, we are gonna have gravitational acceleration for the particle, which is gonna be downward, okay? So the acceleration of the particle is gonna be constant and also it's gonna be g downward, right? Because my coordinate, the positive direction of my coordinate is upward and acceleration is against that, so we have to say acceleration is negative g. And g in US units is 32.2. So the acceleration is negative 32.2 foot per second square. And because acceleration is constant, then we have these three algebraic equations. Velocity is equal to initial velocity plus a times t. Position is equal to initial position plus initial velocity times t plus 1/2 of acceleration times t squared, and 2 times acceleration times displacement is equal to velocity squared minus initial velocity squared. So these are the equations that we are allowed to use here. We can use the other three equations too. They are general equations and they are always valid. But these equations are simpler because they are not differential equations. So let's find h first. How we can find the location of this top point C. So what information do we have here? At the top, we know the velocity is going to be equal to 0, right? So Vc is equal to 0. At the beginning, V naught, it's given. It is 80 feet per second. We know the initial velocity and we know the final velocity at this point. And I want to find this displacement. So what equation I can use among all of these three equations? If you think about it, you have two options. You can use this time independent equation because I don't care, and also I have no information about the time which this particle goes from A to C, right? But I know the initial velocity, I know the final velocity, I know the acceleration, and S naught is equal to 0 here, right? So I'm looking for AC, this distance, which is gonna be S here. So I'm gonna have only one unknown if I use this. So probably the best option is this. The other option is you can use this equation. You know the velocity at the end, you know the initial velocity, you know acceleration, you can find time. You can find the time from here to here. Then after finding time, you can put it in the second equation to find the displacement from A to C. That's another option. Let's go with the first one. I'm gonna use the third equation. So let's call them 1, 2, 3. From the third equation, I have 2 times acceleration, so it's going to be 2 times negative g, because acceleration is negative g, times displacement s minus s0. S0 is 0 here, right? And from here to here is going to be my s, which is 50 feet plus h, right? From here to here. So I'm going to have 50 plus h. This is s minus s naught here. Is equal to velocity at the end squared, so it's going to be 0 squared, minus initial velocity squared, so minus 80 squared. So if you look at this equation, the only unknown here is h. We can easily find h from this equation. If you do the math, you're going to see h is going to be equal to 49.4 foot. Again, g is equal to 32.2. So we found h. And in the second part of the question, which is asking about the time and also the velocity of the particle at point B. At what time it's going to hit point B, and also what's going to be the velocity. Again, look at these three equations. Which one is going to be useful to find time? Can I use the first one? If I know the velocity at B, the final velocity, then I can find the time from this equation. But I still don't know what is the velocity here. Can I use this one? I know the final position of it, right? S of B is going to be 50, right? The location of B in this coordinate is going to be 50. And S0 is 0. Initial velocity, we have it. Acceleration, we have it. So I can use the second equation to find the time, right? And third equation, I can use the third equation to find the velocity, because velocity at b squared minus initial velocity is going to be equal to 2 times acceleration, which we have it, and the displacement s minus s0 is going to be 50, right? So I can use second equation to find the time, and also I can use third equation to find the velocity. Or after finding the time from the second equation, I can put it in the first equation to find the velocity at b. That's another option. So let's start from the second equation to find the time. S at b, I'm just rewriting this equation, is equal to initial position of the particle, which is 0, plus initial velocity times t. Then g is equal to negative, a is equal to negative g, so negative 1/2 of g, or 32.2, times t squared. And if I put the numbers and also bring everything to one side of the equation, I have 1/2 of g times t squared, which is going to be 1/2 of g is going to be 16.1 times t squared. If I take this to the left side of the equation, I'm going to have negative v0 times t, and v0 is 80. And s of b, the location of b in this coordinate, is 50. So plus 50 is equal to 0. So we have a quadratic equation here, and you know how to solve a quadratic equation. And of course, we are going to have two solutions for it. So t is going to be equal to 0.733 seconds, or t is going to be equal to 4.26 seconds. We got two solutions. What's the meaning of that? The time for this particle to hit point B is, you have two options for it. Which one is going to be the correct solution? The second one is going to be the correct solution. And the physical meaning of the first one is the time, this time, 0.733, is the first time that this particle is hitting this height, right? Then it goes up, and after coming back at time 4.26 seconds, it's gonna hit the top of this cliff. So the first time is the time which is passing at from point B and goes upward. So this is not our solution. The second one is gonna be our solution. But this solution has a physical meaning, right? This is the first time that this particle is hitting this height. Okay. So after finding the time, I can put it in the first equation to find the velocity. So if I use the first equation, velocity at B is equal to initial velocity plus acceleration times t. So it's going to be equal to 80 feet per second plus acceleration, which is negative 32.2, times time, which is 4.26. And if you do the math, velocity at B is going to be equal to negative 56.4 foot per second. And why this is negative? Because in our coordinate, that's going to be a negative number, right? Because the velocity of B is downward, and our coordinate is the positive direction of the coordinate is upward. That's the reason we found a negative number for velocity of B.